name is Mario, and this is my final project presentation. I will be talking about Light GBM, a new efficient version of GBDTs. I will divide this presentation in 4 parts. First, I'll talk about motivation and problem definition. Then, I'll be talking about my implementation of this project. I will follow with the evaluation of the model. And finally, I will do some take-home messages. Let me start talking about why I chose this topic. When looking for project ideas, I found this novel algorithm that was released in 2017 by Microsoft. It introduces some novel concepts and challenges tasks. It also attracted me because of its potential in future works. The goal I took for this project was to reduce some implementation in several researchers' papers in which this algorithm was used. Also, I wanted to learn about it so I could be able to use lately for my own purposes. Finally, this project will mainly focus on binary classification tasks, but it can also be applied to other fields. I will continue by talking about my implementation for this project. First, let me introduce the datasets I chose. First, let me talk about the flight delay, where the goal is to predict if a flight will be delayed more than 15 minutes. Then, the sepsis detection, where given a patient health record, it should say whether it has the syndrome or not. And finally, the GINA, which is a subset of the MINIST, where the goal is to say if a number is even or odd. As you can see, all these tasks are binary classification tasks as mentioned in the previous slide. For this project, I will be using some basic packages as can be NumPy, Pandas, or Matplotlib. Finally, some other useful functions I'm using are the AUG score, the standard scalar, the ROC curve, or the training test split, all from the sklearn module. The implementation was developed in a Google Colab session due to lack of memory and local resources. The steps I followed to perform this project are the following. First, I loaded the data using Google Drive as Pandas data frames. Then, I performed some data preprocessing and feature engineering to the data to tackle problems as missing values. Applied some dummy columns to categorical data features and standardized some variables. I follow this by training the model by dividing in train and test sets, initializing the hyperparameters and imputing them to the training function. Next, once the model was trained using the training set, I pass the testing set and predict both the results and their respective probabilities. Finally, I evaluated the model performance using metrics as the accuracy and the AUG score. Now, let's see how the model performs in each dataset. The metrics I use are the accuracy of the prediction and the AUG score of the probabilities. As you can see, both accuracy and AUG score behave quite good even in the worst case, which is in the airline dataset. In this case, I obtained an accuracy of nearly 80% and an AUG score of around 0.74. For the sepsis dataset, results improved a bit, giving an accuracy of almost 95% and an AUG of 0.83. Lastly, the best performance was achieved in the GINA dataset, where the accuracy obtained was of 96%, but the AUG score was almost 0.99. As the goal was to reproduce the original implementations, I will compare those results with the ones obtained in the original authors' papers. These are my AUG for each dataset. They are all quite good results even in the worst case scenario. And these are the comparison with the original papers. As you can see, my results are quite similar to the ones obtained in the original papers when using the Light GBM algorithm. I will end this presentation with some brief home-take messages. This algorithm has proved itself to be a great model to be used. I want to be critique and improve some possible aspects made in this project. And finally, I also want to take this project as a model for future works. Thank you very much for your attention.